when these tools kind of overnight turned from something that like some of us nerds, let's say, were working with these tools, but kind of overnight, the whole world got access to them. Everything changed, I think, at that moment.
Welcome to VoxDevTalks. My name is Tim Phillips. AI's boosters claim that it is going to revolutionize growth in a developing world. The skeptics, many of whom are economists, point to a thin evidence base and the risk of unintended consequences. Now, this is not an easy question to research, not least because the underlying technologies are literally changing by the day. Well, one of those researchers is David Yanagizawa-Drott of the University of Zurich. And when he was visiting NYU Abu Dhabi recently, I caught up with him to talk about AI, his research, and how economists can influence the policy conversation. David, welcome to VoxDevTalks.
Thanks, Tim.
David, your background is in political economy, it's in development. What got you interested in AI?
Yeah, so I think it was probably around 2019, I want to say. I sort of vividly remember one moment. I'm sure there was like a sequence of things, but so I had used some tools from machine learning to do research, like image classification tools, kind of sentiment classification tools for text, for example. Also toying around a little bit with studying political language, political speeches, and see if you can sort of classify different types of political speeches. And unless you want to hire sort of research assistants, for many, many hours to read through, thousands of pages of text and looking at hundreds of thousands of images, which is very costly, you could use these tools. So that had started, I think, before 2019, but there was one playbook at the time, which was very clear, which is what's called supervised machine learning, which is basically whatever task you're trying to solve, you have to get quite technical on your own because you have to get first a data set on your own that has what's called ground truth, which is human labels. For example, if there are pictures, let's say cats and dogs, just to make it simple, you need pictures of cats and dogs, and then you need humans to say, this is a cat, this is a dog, and then you need many of those. And then you feed that to a neural network, and it learns how to classify whatever classes you're interested in, right? So that was sort of the playbook, and that was true for text, that was true for images, that was true for audio, whatever you want. Then in 2019, I was listening to this podcast because I'm an economist, I'm not a trained sort of computer scientist. So I was listening to a podcast on machine learning just to kind of like listen to what was going on in the field, And then they were talking about this new model from Google called BERT. That seemed like magic. And I would go to the gym in the morning, and that's when I tend to listen to those podcasts. And I had to sort of stop my workout to really listen to what they were saying, because what they were saying sounded insane to me. And what they were saying was, look, you don't have to, you just take this model from Google called BERT, and you can just tell it what you want it to do. So for example, if you give it some text and say you want to classify it as this conservative or liberal speech, it will just do it for you. And I was like, that's not how things are supposed to go. It's like, how can you can just tell it anything and it will just do anything for you? So that's why it seemed like magic. So, but these were serious researchers that were discussing this, like kind of, technical podcasts. So it seemed like some sort of breakthrough, I would say. And so that got me interested in sort of these what's called, that turned out to be an architecture called transformers, which later, we call large language models. And after that, GPT came, GPT 1, 2, and 3, and then 4. So I think that was like one key moment when I was like, wait, this seems to be a very general purpose technology that could have lots of downstream application, not just for research, but actually for society as a whole. Now that was an evolving thought, but I think that was one key moment in 2019. I didn't at the time see the potential for social impact and impact on the economy and so on. That was several years later that I realized that. That was probably around ChatGPT release when these tools kind of overnight turned from something that like some of us nerds, let's say, that sort of are into coding and data and you know we kind of were working with these tools, but kind of overnight the whole world got access to them, one version of these tools, and sort of then the kind of everything changed, I think, at that moment.
Everyone has access to the tools, but the story of the application so far, especially with their social impact, seems to be a high-income country story, a global north story, doesn't it? Because that's where we've got the tech giants, that's where we've got the infrastructure, that's where we've got the obvious applications of it. Is there a danger that these tools will be mostly employed in high-income countries and will widen that economic gap between global north and global south?
So I have sort of a positive take and a negative take on this. Sometimes I go back and forth. Let me start where I think what you were alluding to, which is, I think, a very natural starting point and the one that concerns me. So the technology currently is being developed clearly in the global north. It's very concentrated. It's basically coming out of a few labs in Silicon Valley. And China also has a couple of labs. So clearly, sort of the technological frontier is being driven by rich countries, and they are being developed for deployment in an ecosystem infrastructure that corresponds to a rich country, right? So things that we take for granted, the internet at kind of relatively high speed. You can go to, let's say, ChatGPT, not only text, but also if you wanted to send that image, you can send that image. You can even get back an image. You can get back a whole report. All of those things are bits flying over the internet, and we have high-speed internet. So that's just one thing that sort of complements the technology, right? If you have super slow internet, it would not be a great user experience. But it's not just the internet. There's a whole host of infrastructure that complements the development of generative AI, large language models. For example, like cloud infrastructure. Then, of course, you have language itself, which it's being trained on languages that are prevalent in global north. So there are numerous aspects like that will tell you that this is a technology that's being developed in rich countries, and it's going to get deployed quickest and fastest in the rich countries. And so if the promise of AI, which is that it's going to have a major impact on the economy in terms of making people more productive, which raises incomes, perhaps improve various, let's say, in healthcare, lower cost of healthcare. We're going to get better healthcare. Maybe in education, we're going to get even better education. Various things like that. Then it would seem across various metrics, where it's income per capita or longevity or various health aspects. All of these gaps that we already see that are huge might increase, right? And so I think that's a real concern, and that's why I've personally decided, look, I want to do research on figuring out how these technologies can be tailored and developed to solve social problems in global south, for goals such as, you could imagine, sustainable development goals, things that we all agree are important goals. So that's sort of what pulls me to focus on global north myself and my research, partly because of that concern. Now, let me tell you, I haven't told you yet why there are also reasons to be optimistic. And I think there's a path for this to be the great global equalizer. Um, let me tell you like couple of ways to think about it. So what are these large language models really doing? Well, they seem to be storing all of these human knowledge that we have from books and scientific reports and everything that's been written on internet. And it's condensing all of that knowledge and storing it in a neural network. That human knowledge that has the cutting edge scientific knowledge, the cutting edge knowledge when it comes to whatever material science or cancer research or how to treat children that have diarrhea or various things like that. Well, that knowledge seems awfully useful potentially in global south. And if you think that one of the constraints currently is the lack of that knowledge transfer from global north to global south, right? Because traditional pathways is you have to educate people to become doctors and teachers. If you want to teach someone coding, you have to learn coding yourself and become an engineer, etc. And of course, we want to have human teachers, we want to have human doctors and nurses, etc. But it's just a reality that it's very costly to train people to have the latest expertise. So actually, it can potentially radically reduce the costs of transferring knowledge to people in healthcare and education, in various sectors, in companies. And that in of itself seems to, because if then take global, then the level actually, the low level actually now they're able to jump up a lot because the baseline level is so low. Whereas in the global north, we have it pretty good already, right? So the marginal impact of this technology may not be as big for that reason.
One of the applications of your research that you've just published as a working paper is RCT that you did in Ghana, where you're looking at the application of generative AI for people who are applying for a job. Why is this an interesting question? What sort of jobs are we talking about?
This was one of the first projects I started sort of doing field experiments in Africa. Actually, yeah, I ran it. I think it was like 2 years ago, actually. So we've been dragging our feet, but that's partly because it's sort of hard to write a paper when things are changing so rapidly. And maybe we can come back to that later.
Yeah.
But this is studying labor markets, and something we're seeing now that's actually happening because of ChatGPT. So this is one of the reasons. When we had the idea, ChatGPT actually didn't exist. So I thought, hey, why don't we run an experiment where we show the potential power of these tools in the labor market? But then ChatGPT was released, and now it is in the labor market. So we're actually studying a phenomenon that is there. So that in many ways, that makes the paper more relevant. Unfortunately, I can't look bright and say, hey, I think this is going to be a thing. But so what we're seeing in the labor market is two things. Because the cost and access to this technology is now so low, you can just go on the internet, like for example, ChatGPT. It's not hard. You don't need to know Python coding. You don't need to know anything about large language models. You have this very simple interface. That means that employers currently can use these tools to screen applicants. That's on the demand side of the labor market, and that's already happening. And at the same time, what's happening on the supply side, so people that are applying for jobs, they're actually using these tools now in their application material. So we have gone from a situation. So estimates suggest that about 40% in US data that I've seen of job applicants are using ChatGPT to shape their application in various ways, the cover letter, etc. So what happens to matching in labor markets when both the supply side is driven by AI usage, where people, in explaining who they are and what they're good at, is written in part or wholly by a large language model? And on the demand side, you screen for talent by using a large language model that follows some criteria to look for talent. It's really unclear what's going to happen in that kind of situation.
Yeah, instinctively, we think about technology as maybe bad in this case. I notice that there's a lot of job advertisements at the moment that are saying, please don't use these large language models to help your application. We want to hear from you. And a lot of people are worried that they're going to be rejected by the algorithm and not get a chance to be themselves. Are there also positive outcomes for this?
Yeah, well, the paper actually finds, I think, at least from the perspective of the organization we worked with, quite positive effects. So maybe I should explain a little bit what we did and what we found. On the demand side, we work with a nonprofit that hires teachers to go 2 years to teach in underserved areas in rural Ghana. So it's sort of a prestigious program. I think it's influenced by Teach for America, where recent university graduates, very, very high skilled people, sign up for 2 years to basically at very low salary, basically no salary, go and live in a rural village and teach children in a local school, typically actually in a language that in an ethnic group they're not even coming from themselves. Now, this organization gets about 1,000 applications every year, and traditionally they had people in the organization, previous teachers, screen for the applicants, which is what most organizations have been doing forever, right? But these are, this is quite a lot of material, because not only do they have the CV, but the main part is actually this organization asking them to answer certain questions about why they want to become a teacher, what is their teaching philosophy, various aspects of how they approach challenges, and they have to write essay answers, essay questions. So so imagine like a team of 10 teachers going through 1,000 applications. That's a lot of work. And so, you would hope that they would read every application very carefully, think about the application, looks at the criteria. It's a hard task. It's a tedious task. I imagine it's actually not particularly fun, but it's super important, right? Because this sets up who gets interviewed, right? So this is the next phase. But large language models can look at all of that text. They are not, they don't have, anything else to do. And, if you say follow these criteria, in theory, they should be able to pretty well follow the criteria. Whereas with humans, I guess you can there's sort of, you can question how well people can do this, both for cognitive reasons, just because it's hard, but also, we're all busy, and, nobody's really perhaps checking very carefully if I'm doing a good job or not, right? So the incentives aren't super strong also. So we worked with this nonprofit, and we said, hey, why don't we randomly assign so that some of these, some percent of these applicants get screened by the large language model. So to come back to your question, if you think of this as, again, lowering the cost of intelligence, here's a task. It's pretty well defined. This model can do this in 0.6 seconds at an extremely low cost, whereas it takes many minutes for a human to do this, right? So you reduce the cost by, say, 100x, just in terms of time. And then, if you want to think of this in monetary terms, it's also a huge cost drop, right? So that's already there. I think even if the level will be the same as humans, right? You've already, made the process much more efficient. But then it turned out those files that gone through the AI-based grader versus human-based, we then see what happens through these two pipelines, because the next stage is very in-depth interviews with a different team, and they do have to do practice teaching, they do psychological evaluations. It's a full day of sort of in-depth testing. And then they give offers if someone is above a bar. So we see huge effects. The AIs, the likelihood that the likelihood of hiring success, which is that the person went through the interviews and was offered a job and eventually was deployed as a teacher, that goes up by about 70%, right? So that's a huge improvement.
That's huge.
And that was not clear to us at all going into this project, because you can make the argument. I even thought about it this way before, which is, look, these large language models, again, they've been trained mostly on Western data. They don't know anything about the local context. Obviously, they have not taught kids in rural schools, right? So I would imagine that the human teachers have a much more holistic understanding and sort of tacit knowledge about what does it take to become a great teacher for this type of environment, right? As opposed to some sort of slightly autistic sort of grading based on criteria that the organization set up. And based on that logic, the AI might not do well at all, right? And this, we actually use GPT-4 here. We didn't train our own. So also at the time, GPT-4 had just been released. So there had been no experiment at the time of any, as to my knowledge, any real world experiment with GPT-4. So like we just had no clue. So that's one of the main results of the paper. But then we actually had three pipelines. I have mentioned two of them. But the third pipeline was actually when the human graders had the AI as an assistant. So it was still the human graders that made the final call. It was just the recommendation from the AI came in before they made a final decision. And I thought this would be the sweet spot because, okay, now the AI can just go through all the text, give a recommendation. I'm going to read it as well. And then maybe we can sort of combine. I, the human, have a little bit more tacit knowledge. I can avoid some like stupid mistakes, pitfalls. And so I thought that would be the most impactful. But it turned out not to be the case. It had a little bit of an effect, a little bit of improvement in finding the good teachers, but it was not statistically significant. And so one of the puzzling things, sort of when we struggled with the paper, is why? If the AI alone improves hiring success by 70%, and you can just give that recommendation to human, like why does it fall off so much that it's not even significantly better than human only? And I don't know if we speculate in the paper why that could be the case. But just if you take that as it is, I mean, this is just one case study, let's say, or one example, but it speaks to a much broader policy debate, which I'm sure you're aware of, which is, okay, the economy, we have all these tasks in the economy, things that needs to get done. How good would these models be? How good are they today? How good will they be a year from now, 5 years from now? And the big labs themselves, like OpenAI, for example, they're explicit. They're building what they call AGI, artificial general intelligence. And they want to reach human level performance for every single cognitive task that humans make, and then go beyond what's called super intelligence. And if they succeed with this endeavor, it's basically a straight path to what's called replacement or substitution of labor. Because now you're going to be able to do the same thing at a fraction of the cost, 1/100th of the cost, at 100x speed, right? Of course, organizations gonna, many of them are gonna then, do the efficient thing. So that's a concern, I think, and economists, not just development economists, but just in general, labor economists are thinking hard about, will that kind of economy arise soon? What's the likelihood? Is that a good thing or a bad thing? Is it maybe a bad thing in the short run, but a good thing in the long run? Anyways, there's a lot of debate around that, right? But then what's the alternative then? Because this genie is out of the bottle, right? That's the expression. Like this technology is not going anywhere. It's just becoming better and better. Well, there's an alternative view, which is called the augmentation view instead of the automation view, which is that these tools will make people just more productive, right? So it will still be humans in charge, whatever is the task, whether it's providing medical advice as a nurse or doctor, or tutoring as a teacher, or a team of people selecting who to hire in an organization. And these tools can just augment people and make them better at whatever they're trying to do. So we thought, here's a very nice test of this. We have 3 pipelines: the status quo, human only, and then the automation pipeline, and then this augmentation pipeline. But this augmentation pipeline didn't do much, right? So there's just one example where you have to stop and think, okay, but why? And is this generalizable at all?
Well, when you have conversations at the moment, David, with people who are creating these applications for AI in every context, they are always keen to emphasize that a human in the loop is the jargon phrase, isn't it? Is important. And you have 2 years ago used standard technology that wasn't trained in the markets in which it was deployed, and you have found that the human in the loop really wasn't necessary at that point. It's something that makes us, as you say, think again about how we can deploy this technology.
100%. But here's my view on this. Why, and this comes back to the issue of global south, and sort of, we should not make the mistake of taking the technology as given. This technology is being developed by humans. But if your view is just, well, let the big labs develop it, and then we're going to take that and just sort of use it, like you're buying a Samsung television, right? And then Samsung decides what the Samsung television is, but you can't change it, right? This technology, especially with open source, I would say, you can actually shape the technology if you put in the resources, and have the technical know-how to shape it in a way that you deem desirable. So at my lab, we use this concept we think of AI as a gap learning system, where you have a goal, and so that's a G, and then this system can take some actions. Right, in the teacher case, it was like selecting whom to interview, and the P is perceptions. It can observe some data, something about the environment. In this case, it could read the files. It also had access to the organization's criteria and the broader mission of the organization. Right, but those 3 components, any AI system, it's basic. I'm using the Wikipedia definition of AI, right? So those 3 components always define an AI or a neural network. But then there's a learning component, which is over time, this system can learn how to take actions to better fulfill the goals, right? So, but we just, in this first experiment, we just deployed ChatGPT-4 just to kind of see what it can do. But, we are now like 2 years later, and, my thinking has evolved a lot, and the technology has evolved. And I think we're at the moment now where we should take a step back and say, whatever context we're interested, whatever social problem we're interested in solving, whether it's in the medical space, in healthcare, and education, or in finding good teachers, whatever, if we're thinking about developing and testing a system, what should be the goal of this system, right? So, for example, when it came to the hiring of teachers, the hard question would be, wait, how can you augment humans to find teachers that are the best teachers, right? And that's a harder question, but it seems like the question we should be investing a lot in, because now you're on a path towards augmentation. Now you're on the path towards complementing humans. So humans must have some comparative advantage compared to any AI system. That's true today and must be true in the future. But and then you can develop technology to be complementary to humans.
How can you do this in either policy or regulatory terms to be able to say that augmentation is the superior goal?
So you have to engage in what's called exploration. So, but I mean, the regulation, I don't know exactly what you're alluding to here, but of course, you have to be careful, whatever context you're in, and make sure you're following rules and regulations, right? But I think in many use cases, that isn't really the thing. So, kind of a constraint, right? So here, this organization is just trying to find the best teachers, right? An augmentation view would be to design the system so that the human decision maker, you facilitate that decision to be the best possible decision, right? So, for example, maybe the human decision maker needs to have some feedback on past errors that they have made, right? So we have very little feedback currently in most of the work we do. We have very kind of arbitrary feedback, right? So we're doing this podcast now, right? If you were a professional football player, playing for Manchester United, and there's a game and you lose or win, afterwards, regardless, the coach is going to sit down, go through the tape, and sort of say, here's what we did good, here's what we didn't do so well, and next time we need to do even better, right? And, this feedback loop. And that's how you learn, right? But so much what we do in society is doesn't have that feedback loop, just very kind of obscure feedback loops. Maybe you see the number of clicks or likes, maybe something like that, but you don't know exactly why someone liked it. So once you start to introduce feedback loops, the systems, the neural networks can learn, first of all, but then they can learn, maybe humans need to have feedback as well, right? Maybe the systems can help with feedback. And so you get this sort of bi-directional potentially improvement. And there are just so many wide open questions once you start asking a different type of question compared to sort of the question that we asked, which is like, okay, we had ChatGPT, or we had GPT-4. What happens if we automate with that compared to we give the output of GPT-4 to a human as it is and see what they do with it?
In development situations, though, very often there is less potential for feedback. There is less data available. It's harder to find. The existing data that you're starting with is incomplete. Is that likely to be a problem?
No, absolutely. And this comes back to what we said earlier in the podcast, which is the whole infrastructure that complements these models is the best in global north, right? So the initial training data is better, but then once you deploy systems, you can do what's called reinforcement learning, which is this feedback loop, right? You define a goal, you let the system learn based on trial and error, and it constantly improves, right? This is where we're standing now today in 2025. This is now being deployed quite extensively. I don't think a lot of users are aware necessarily that this is what's happening, but this is what's happening, right? But it's not happening global south, right? And that's what I'm saying. Like if we just sit here and talk about things, it's nice to talk to you, Tim, but if we just sit around and talk, like there's a path where that may not look so great, I think, from a global inequality perspective. But maybe, I don't know if I'm over optimistic, but I also see a great opportunity here, right? Like if we put our resources to it, if more people get engaged, and I'm hoping economists and AI engineers and policymakers get together and try to tackle social problems, think hard about, can we deploy some AI system here that can initially be good, but over time become even better? What would that look like? And maybe there's a lot of low-hanging fruit that's available. Again, because, healthcare systems, for example, aren't that great. So maybe just a little, some slight improvement in how medical advice is being given to people, or how doctors are being augmented, or teachers, or what have you, tax collectors. Maybe you can have high returns.
David, your augmentation argument, based on the fact that the path of technology is not inevitable, that's something that it's an argument that also Daron Acemoglu has made, Simon Johnson's made as well. You are influential voices, but there is also a very influential voice coming from 40 years of the technology industry. What do you think it's going to take for your argument around this to influence how policy is made?
Well, it's the same old story, I think. You have to have people that are mission-driven. If you just let the market, quote unquote, profit-driven organization dictate all the terms, you can get a lot of great things, but you can also get some not so great things. And so again, we have an ecosystem for improving things in the global south. There are various philanthropic organizations that are willing to put down resources. There are, obviously governments that support efforts in global south. And, I talk to policymakers in global south a lot these days, and they are very open to trying out things. And they're saying, look, like, for example, I'm talking to, youth ministry in Ghana. They have huge youth unemployment, and they're very eager to get going, right? But we need resources. So, but then I think I don't want to sound too negative, but currently AI isn't like the top of like board meeting agendas for these donor organizations. It is maybe not even on the agenda, I would say. And so where are the resources going to come from, right? Like Silicon Valley is investing billions and billions in making this technology. How much are we investing in Africa currently? I mean, I haven't run the numbers, but I'm pretty sure it's going to be a very, very, very small number. Again, I think there are reasons to be optimistic then, or let me put it this way. I think a year from now, maybe that's 2 years from now, I think there's going to be a top item in board meetings for all of these organizations. Some are gonna wake up earlier, and in fact, I know there are some already that are sort of thinking about like, what can we do? What are we doing about AI? What do we have in our portfolio about AI? What can we do? But there's like no competency currently in these organizations. They don't quite know where to start. So my hope is through these kinds of podcasts and conversations, the right people, get together and try to make something happen. But we're in it for the long run, Tim, aren't we?
We are, but there must be a lot of researchers, a lot of development economists who are desperate to research these sort of questions that you're talking about, your natural allies in this. The thing we started off with is the research you're doing here. It's great, but as you pointed out, it's now a couple of years old and things have changed a lot. Does the pace of academic research limit the ability of the researchers to take part in that policy debate?
Yeah, it's very interesting because the pace of technology is insane right now. I've never seen anything like it. Now, I stay on top of I like every day. I'm going on Twitter. I'm following certain, I'm trying to stay on top of what's happening on the technology front. But it is quite. I mean, just comparing, now early May to, just a few months ago, 3 months ago, 6 months ago, 12 months ago, the technology is very different. So how do you do research? Let me take another example. The one technology that economists have studied a lot, which is fertilizers in agriculture in Africa. Okay, here's the technology. The question has been, we know it's profitable, we know it increases yields, but farmers aren't using this technology. Why? Right? And how can we increase technology adoption? Right? Now, if you study fertilizers today are, fertilizer today versus 10 years, 20 years from now, like pretty much basically the same chemical compounds, right? So the question is sort of pretty stable over time. Whereas this technology, is different now in May 2025 compared to May 2024, right? So the question of, let's say, technology adoption, why aren't people using it? This technology, if you ask that question in 2024, you'll have very different answers from in May 2025. So I don't know, because this is unprecedented. I think, essentially, nothing comes to mind, at least in my lifetime, where the pace of technological progress is so fast. How do we write the kinds of papers that we development economists write, which is when you go to the field, you partner up with an organization, you fundraise to get money for it, or you apply for some grant. Usually from the time of like initial idea to maybe you have first funding, it can easily be a year. And then maybe you roll out a little pilot just to make sure everything kind of works. And then maybe 2-3 years later, you have the first results. This is not very uncommon, and some projects take even longer. I don't know what happens in that kind of scenario. I think the way to think about it, and economists tend to be good at this, is to try to think of a deeper mechanism that you're trying to establish or test for that isn't super dependent on the specific technology that you're studying. At least that's the playbook, I think, that economists tend to like. But at the end of the day, you're studying a technology, and if the thing that you studied and you come out with a result 2 years later, nobody's going to care about that specific technology because it's already obsolete potentially. Yeah. But still, economists, once you start working on this technology and spend a lot of time and effort and so on, I think you can still talk with policymakers and come up with good policy advice nevertheless, I think, based on the current state. And also, we don't have a choice, do we? We are supposed to be studying the economy. We're supposed to be studying how to improve the economy. And here's a technology that's likely going to have major impact on the economy. So, we just have to do, roll up our sleeves and get to work.
I look forward to finding out what that work produces. David, thank you very much for talking to me.
Thanks, Tim.
The paper on David's research in Ghana is called Finding Talent in the Age of AI. The authors are Kobina Awuah, Ursa Drank, and David Yanagizawa-Drott. Also, David is the founder of the Social Catalyst Lab, which is investigating questions like this. You can find that at socialcatalystlab, or one word, .org. This has been a VoxDevTalk. The best way to make sure you don't miss an episode is to follow us. You'll find us wherever you get your podcasts. Our past episodes, as always, are at voxdev.org, where you will also find articles about topics like this. And if you like us, please tell someone else about us and leave us a review.